Okay. Hey, today we have some different formulas. These are the double angle formulas over here, and then there's some half angle formulas. But look, it's just like when we were using the sum formula or the difference formula. We realize there are formulas out there. We go find the formula, and then we just try to use it. We're not going to try to memorize all these formulas. It's not worth it. They're written down in books, or you can just look them up on YouTube or on Google or whatever. But I've got my double angle formulas here, and some tangent one here, and then some other variations of sine squared, cosine squared, or tangent squared. Sometimes these are useful when you're trying to solve an equation and trying to rewrite it in a different variable or a different function, right? Like if you have a cosine and a sine kind of mixed equation and you want to get it all in terms of sine, sometimes you'll be able to use some of these formulas. And I hope this is helpful. I'm going to show you how to practice this idea. But before we do that, I want to show you, like, how did they develop this? It's not actually very difficult to see this formula and its development. Let's say you had two angles that were the same, like instead of an alpha and a beta, two different angles. Let's say you had the sine of alpha plus alpha. Wouldn't that give me the sine of 2 alpha, right? That's what we're talking about kind of here. 2 theta, different variable, different Greek letter, but it's really the same idea. Exactly the same idea. So what would this look like? It would look like the sine of alpha times the cosine of alpha plus the cosine of alpha times the sine of alpha. And then we look at this and we go, well, is there any kind of, factoring or simplifying or anything I can do to make this, more clear? Well, there's a term here that's identical to a term over here. So there's two of them. So we just write 2 sine alpha cosine alpha. Okay, that's where this one comes from. Now, I'm not going to prove these guys down here. I mean, we could. It would be doing something similar to what I just did right here. And you can see that, I mean, this is pretty darn close to the trig identity, but it's not cosine squared plus sine squared. It's cosine squared minus sine squared. And if I did prove this one, you could replace, one of these two with 1 minus sine squared or 1 minus cosine squared over here, and it generates these two formulas. So sometimes it's beneficial to have, you can see that cosine of 2 theta has 3 options. So sometimes you're going to choose one over the other just for ease of doing the problem. Okay. So like I said, I'm not going to prove anymore, but it's not that hard to prove these guys. When I come right down to it, what my goal is to practice this idea, like to get the practice of saying, hey, there's got to be a formula out there that'll help me find this. And then if I find the formula, can I use it? Right. So in this case, we're trying to find the sine of 2 theta, right? And like some people realize, hey, there's multiple parts to this problem, but once I set up for one part, then it's just a matter of taking that information and sticking it in different formulas, right? So let me make that real clear here. The sine of 2 theta is going to be equal to 2 sine theta cosine theta, right? Or alpha, whatever. 2 sine theta cosine theta. So I have the sine of theta right here. So let's put that in 3/5. It helps our brain say, well, what do I still need to find? I need to find the cosine of theta. Now, good for us that we have some practice doing this, right? You make a little drawing. You put the first quadrant down as your main focus, right? Here's my first quadrant. And I say, okay, well, it's telling me that the sine is 3/5. Now, I've done enough of these where I know this is 4/5. And you might say, whoa, why is that the case? Well, if I had a right triangle and this leg over here is 3/5, I could multiply it by 5, and it would become 3, right? So this would become 3. Now, before I multiplied it by 5, this side over here was 1 because we're back here in the unit circle, right? If they tell us the sine of alpha or theta, whatever, is 3/5, that means that the hypotenuse is 1 long, right? So if it was 1 long and I just multiply this one by 5, I got to multiply this one by 5, right? So if I had a 3 and a 5 on the hypotenuse, then I know this leg down here is 4. But I can't leave it like that. I got to get it back to the unit circle. So I divide everything by 5, and that's why this adjacent leg is 4/5. So I'm going to put 4/5 right in here. I think today you're going to find these problems just a hair easier than what we were doing before. 12 over 25, right? You just multiply numerator times numerator, denominator times denominator. And then when I double, like 2 is the same thing as 2 over 1. 2 times 12, that gives me 24 over 25. All right. So, that's what we're doing today. We're going to go find the formula, and then we're going to try to use it. All right. Let me just try another one here because we can't see this formula. So this was part A, right? Part B, I know you can't see that formula either, but it's similar to sine 2 theta. So let's try half. Okay. So let's try, half theta. And let's see if that's any different. And you know what I'm going to do? I'm going to do that in my second video, because if you're like, hey, I get it, no, so I'm going to go find the formula. I'm just going to use it. You might be okay from here on out. All right. Thanks for watching my video. Appreciate it.